Okay, yesterday um, we finished off that cell class. So we just kind of typed our code in real quick, right? Remember at the end? So just as a quick review, in the draw method, we have to pass in a graphics object because this is just a class. It doesn't know anything about drawing or anything. Like, so it's not a class that's meant to be drawn with or anything like that. So we pass in that graphics object, okay, and we had to make sure that we have the system drawing library included in, so it understands what a graphic object is, and then we can use that within here to draw. Now, because we're passing in the graphic object, we can pass in any surface that we can draw on. So more or less, we could pass in a form, a button, a panel, a picture box, even a text box, like all those kinds of things. They all have drawing surfaces on there we could modify by using this graphics object. Okay. So all we really did here is we created a pen and a brush to create the actual cell. Black edge on the outside and a filled in white. Okay, that's if we use the constructor that is the default, right? Remember we did two constructors. One it'll set it to black and white, and the other one we actually specify the actual color and size and everything, and then the cell will be generated based on that. We do have properties also that we can use to change the size, background color, and the border color if we wanted to. Okay, so we could do that. What we're going to do now is so this is technically a DLL, so what we can do is maybe build it again. So the DLL gets built. And if you look in the folder where this was actually, where you actually saved it, if you go into the program folder and you go into a section called debug, you'll actually see the DLLs in there. Okay, so we would go. You could go to the folder where we saved this project, and here's my grid test. And you go into the folder ambro.grid. You go. Oh, sorry, you got to go into the bin folder. Okay, and then you go to debug, and it actually has ambro.grid.dll. Now you can copy that and distribute it anywhere. Now, you typically would have to have a setup program to install it because this does require whatever version that we're using of .NET Framework. I believe it's 3.5 or 4 on our systems that we're using. I think it's 4. So .NET 4.0. I think there's a 4.5 or a 5 out now. Okay, so you would have to make sure that's on a person's machine. So what a setup program does, it's a little program. You can even create a setup program through Visual Studio and include your project in there, and then it'll include all the support files, and it'll include a distributable for the actual .NET framework that you're using. So that it'll make sure that that's installed on the person's computer, and then it'll install your program, so then everything should work. Okay? It'll install any DLLs that you use and that kind of stuff. Like I said, we're not really going to get into that kind of thing, but that's something that you could learn very simply once you graduate and from computer science or whatever. That'll be something that shouldn't be a big deal to figure out how to do. So I don't think it's worth even doing here. Okay. But what we want to do right now is use this DLL in another program. Now we're going to add it in the same solution, so this way it would work if we put it in a separate folder or whatever and then included it, but we'll just do it in the same folder. We'll still have to add that DLL as a reference. So what we're going to do here is go to your solution, and we're going to add a new project. So Mark, what we're doing is just inside the cell there, all you got to do is just, I just did a little review for a minute, so you didn't miss anything. We're just going to add a new project right now to test out our cell, so that makes sure that at least that draws on the screen. Okay. So all we're going to do is do add new project. Okay, Windows form. Make sure you switch it, or you're going to end up creating another class library. That's no good. We want a Windows form this time, and I know our project's called Grid Test. I don't really want to use the same name, so then maybe we'll just switch it around and call it Test Grid instead of Grid Test. So switch it around. I don't really like using the same names for things just in case it causes a problem. So this time we'll just call it Test Grid instead of Grid Test, right? Test Grid. I think we called this whole project Grid Test, and then we'll call the program Test Grid. Good enough. Okay. Just set it up so that your form centers itself, that kind of stuff. So center screen, test grid as the text for that shows up in the title bar, and for me only, I have to change the font so that you guys can see things a little better on the screen, or it'll come out, it'll be too small. So but you don't have to do that. So all we're really going to do is we're just going to put a button on here. So the button's going to draw, and inside the code for the button, we're going to draw the cell. We'll add another button later, and then we'll draw a grid. We haven't created the grid yet, right? Because we just did the cell class. So, but we're going to do that in a few minutes. But let's just test this out and make sure it works. So we're going to add a button on here. Maybe we'll just, how about we label this button as, maybe we'll call it cell. Well, maybe we'll call it draw cell. Okay, I got to make it a little bigger. Draw cell. And we'll just call it BTN draw cell. Okay? And then go into the click event for it. Now, if we tried to access cell, it's not going to work, right? So if I start to type in cell, you'll see it doesn't show up. Now, it might access. Look, it doesn't even recognize Ambro Grid because that DLL is not associated to this project. Because technically, even though they're in the same folder or solution, they don't really know they're supposed to talk to each other. So what we have to do is under Test Grid, which we'll set up as our startup project, so that when we press play, that form will come up. We're going to go into references. Remember how we did that to add in the system.drawing? Well, what we want to do here, well, notice the system.drawing is automatically in here because it has to use that to draw the form, right? It's built into the form. So over here for references, we're going to do add a reference again, and I mean we could go to browse and actually go to the folder, but because it's in the same project, like in the same solution, we could go under the project tab and notice that Ambro Grid's there, and then you could just say OK, and it'll actually add that DLL in there. Okay? And when you actually compile this program of Test Grid, I believe, and we're going to test it out in 2 seconds, because we'll just run this. I believe what it's going to do is it's going to go to the Ambro Grid folder in the bin there, and it makes a copy of the DLL, and it copies it into Test Grid's corresponding build folder. I'm pretty sure, but let's just check and make sure it does that. So let's just run the Test Grid. After we add the reference in, we'll run it. Okay, so it shows up. And then let's just double check and see if it shows up in there. If we go in the bin under debug, look, there's Ambro Grid and then the testgrid.exe. Okay, so when we want to distribute this project to our end users, it'll distribute that exe, but it must not forget to distribute that custom DLL that we made, right? Or guess what? Nothing's going to work. Anything in that program that tries to access that Ambro Grid, it's going to just crash, right? These are all just little extra things I'm showing you because, I mean, I was used to doing this because every time or every place I worked at, we had to always make sure everything got distributed. I used to run I used to create lots of setup programs to distribute programs. Hated it though, it's kind of boring. coding's the fun part. That's why I like the web programs were better. These are all the files, they just get copied over to the server, and you just give the instructions, and I didn't have to write any distribution. It was way better. You know, when you go, you'll start to see that when you work for companies, you'll probably create more of web applications than you would actually programs. So if I were you guys, I would just learn for fun like HTML. Know it. So you can put it on a resume. Particularly those of you who are going to go into co-op, make sure you learn HTML. And also I would probably learn Java and maybe PHP too. I mean, these are all little, especially if you're going into like co-op and stuff. You want to be able to compete with the folks that are a little older than you. But if you have a lot of tools that you understand. But anyways, come and see me before the end of the semester, and I'll give you some things that you can learn on your own. Yep. Yeah, it does. I'm not a big fan of it. Like Microsoft tools are, pretty efficient. Like that's one thing Microsoft's actually pretty good at is writing compilers and writing. And when they compile their code, it actually runs very fast. Very good on memory and things like that. Java's not so great. It does slow things down, but it's kind of free too, right? And you can get a lot of stuff for free with it. So a lot of companies are starting to adopt it. All the companies I work with did use Microsoft tools. Some people hate them. They don't want to use them. So it depends where you're coming from. If you're running Mac environment, forget creating apps with the .NET, right? You're going to either do it in Java or you're going to create apps for the, what was it, like, what's it called? Something C, Progressive C or something like that? Is that what they use? Yeah. So it's like a C or C. It's probably very similar to C, C#. So, depends. A lot of people use like PHP with Java in the background. I always worked with ASP.NET, which is the web development tool with my components, DLLs written in either VB or C#. And then those would run. So, and they also have, actually you could create, they're kind of like, here Alex, you could create kind of like DLLs. They're not quite DLLs, but, well, they kind of are, but they're called web services. So what you do is it's kind of like a DLL that you can expose over the internet. So let's say, I don't know, I have a company and to my customers that connect through my website, or maybe they're going to create apps based on some service that I provide, and instead of me giving them all those DLLs, which would be proprietary information, I wouldn't want them to have it, they can connect to my web server and access all the code that they want through whatever services. Let's say I have some sort of GPS type of system, and so someone wants to access that code. So instead of me giving them DLL, they will connect to my web server, and those DLLs could be kind of accessed from there. You want to think of it that way, like all the methods, stuff like that, and then they can embed that into their programs that get displayed to their customers. So maybe Canada Post would be a good example. Maybe if you they will expose web services. I don't know if they do this, but they probably should. They could expose web services that if you enter in a street name, it'll return back what the actual postal code is. Or if I put in a postal code, it'll access the web service on Canada Post, and then it'll send back to me what street and street numbers are available to that, right? So I can do that. So it doesn't matter. Anybody all around the world that needs to do, let's say, shipping and things like that want to tie into Canada Post, I could expose those services through them by creating these web services. If not, how would I get it out to everybody? What am I going to do? Send out a CD with a program that they have to integrate into, right? So that's kind of a newer way of doing things. It's not really open source because Canada Post will provide the methods that you would access to, right? But it's accessible through the internet, and you can even tie it into security and encrypt it. So I can't access it unless I have a username and password. So I have to be maybe a subscriber to Canada Post or an authorized deal or an authorized company that could get access to it. And then they would use that in their, and then they would code their web page to access that web service. And then when it gets used, it'll go through, access Canada Post, send back the information. It seems like it's part of your website, but it's not. It's going, who knows, across the world to get that info. So that's kind of some cool stuff that you can, those are like more modern ways of doing things nowadays. So that's a great way of sharing, you know, your resources with another company very easily over the internet. But you gotta be careful. There's always security and all kinds of personal information you don't want people getting at, like credit card info and all that kind of stuff, right? Anyways, so in order to, let's go back to this here. So in order to use that cell, we just gotta add it to our using, or it's, even though we add it as a reference, it's not part of this file yet, right? So you're going to type in using ambro.grid. Now we can access anything about ambro.grid, and let's just create a cell. Cell, no, it's not here. Where is it? Is it not private? Hold on. Okay, it's not being accessible because we forgot to put public in front of our class. Now, you're going to have to build it. You got to, whenever you make a change, you want to build the class. It's got to be public. If not, it defaults it to private and it wouldn't access it. Okay, so go into the cell, put private in front of class. Okay, and then make sure you build it. Okay. And then now it'll be able to be accessible. There it is. It shows up now. So if I type in the IntelliSense, there it is. Now cell. I'll just put a little lowercase cell in there. Equals new cell, and then it's pretty cool. Like we developed this. Look at that. It's got two options, right? See, I'm just like one of those Microsoft folks there. I created my own little class with all its little. What do we call this? What did I do? I created this constructor, and there's two of them. There's a special name for it. Overloaded. I overloaded this method while this constructor. Okay, and that is a principle of object-oriented programming. Which one? What's that fancy name? It's got a name. Polymorphism. Good. And then an easy way to remember the definition of polymorphism is one name, many faces. Right? So I got one name, cell, but it's got multiple faces, right? It's got two methods. It's got two versions of it. So that's an easy way of remembering that definition. Okay. So in this particular case, let's just test out the default one. Okay, and then we'll do cell.draw. Okay, we have to pass in the graphics object. The easiest way to the graphics object is attained by calling, remember, do you guys remember from last year, or did we do any graphics set this year? We could type in this dot, it's create graphics. I mean, I could create a separate variable for it, but I'm just going to call that right there. This way I don't have to even create a variable. I mean, I could create a variable before called graphics g equals this dot. All right, I'll do it this way. Either way, if I do it this way, it works, or if I pass in G. Either way works. So when you rewatch this in the video, that'll work, the first way I had it in there. Okay? Because that is a graphics object, right? Sometimes you don't have to create that method, create graphics returns graphics object G. That'll get passed in the method and used. Okay, but we can do it this way. And then we got to do X position. I don't want my button to get in the way, so I'm going to say my X position is, let's say 20 pixels over, and let's just say maybe 200 pixels down, like that. Now at the end here we can do G dot dispose. Okay, so in here dispose graphics object. Okay. Now, we don't want to do it inside the other one because once I draw one, then if I try to draw a second one, it won't work. But we could do it here. So if I run this, I don't know, let's see if it works. Hey, there it is. I think doing 10, is that 10 pixels? I think that's way too small, eh? Let's go back and change our default from 10 to 20. I think that'll be better. Yeah, 20 is better. 10 would be too small. So change your default to 20. Okay. What I want you to do now is just change the code around and use the, well, there's a couple different ways we can do it. I mean, I could do new cell. I could go in here and we'll pick the second version. So let's say I want to do 40 pixels and then color dot, the background color, let's say is, what's Biscay? What the heck is that? I don't know. Color dot, oh boy. Whatever that color is. As long as it's not offensive. Sounds offensive. It's an offensive color. Azzurre. I like the Italian Azzurre. There we go. So if I use this, should work. Oh, look at that. It's like a pinky color, and then you could see the outline, but it's very faint. There you go. If you want to draw two of them, it's not really creating two cells. It's just drawing that same cell twice. But it's really, if we call the refresh after the first one, the first one went. I don't think the first one would show back up. So if I did this, yeah, only the last one gets shown. You can also use the properties, right? So if I do cell dot background color equals color dot black. So my background color is black, and I can do cell dot border color. I'm going to make this one equals white. I'll switch them, flip them around. So if I use the properties, even though I set it to 40, I set it to bisque, I set it to slate, whatever gray, these two are going to override it before I draw it. And I can even change the size. So if I do cell dot size, I could set it to 15 pixels. So it won't be 40. So that'll just prove to me that my properties are working. Let me just see. And then there it is. I'll go 60, make it really big. There is white around it. It's very hard to see. All right. You got it working? Let's take a look how this, we got to figure out how we're going to do a grid now. We got to turn the lights off so we can concentrate. If we're going to create a grid, what do we need to know? X and Y in what sense?
Location.
Where the grid starts? Okay, good. So let's say here's my form. The X and Y will be the first spot where the grid, so my grid might go up over here, and then that's where my grid will start drawing. Okay, so the X and Y, so that'll be location. Very good. What I'm going to introduce to you, there's a structure called, I believe, what's it called? I believe it's called size. Maybe we're going to use that because there's an object or a structure built into .NET that's called size, or maybe it's point. I can't remember. I have to look it up. And what it does is it gives you an X and Y value. So let's say I create a property here of a type size, and I call it location. It has two parts to it. It has an X and Y. But so we can have a location X. We'll split it up though. And we have a location Y. Okay, or we could call this even better, top and then left, maybe. Right? This would be top, and then this over here would be its left position. That might work. Maybe we'll use that. Okay, what else? What else do I need for a grid? Yep. Okay, and its size is defined. How would we define a grid? Length and width, or yeah, but well, yeah, maybe we'll use rows and columns. Typically, I use that for a grid. I usually use rows and columns. So we can have rows and columns. Okay. Now we could also pass in maybe for our constructor a default like a default cell. Like, so when I create this grid, it'll make all the cells maybe a certain default. I'm gonna kind of like that. I don't think I'm gonna do that. And you guys do your assignment, you're gonna be customizing this grid to suit the project a little bit better. So I'm gonna keep some things a little open to you, so you have some things to do for that project, other than us doing it all together and then just adapting what we've done, you know, to make it work for a little project, or a little game or whatever. So you can do that kind of thing. If I want to show this on the screen, what are we going to have here? Yeah. So what would I call that method? If I want to show something on the screen, grid what? Draw. So I want to have draw on here. Draw method. We'll probably have to pass in we'll definitely have to pass in the graphics object. Maybe this location can be put inside here. Maybe. What do you think? We could put in graphics, and then just like the cell, we'll put the X and Y. That's where that location. So maybe we don't even need these, because we can do it here when we draw. When we draw, we call draw. It'll set that X and Y will define the left and the top. We can do it there. So then we don't need it. We can expose its properties, but I don't really need to do that. Let me see if we missed anything in here. I'm going to let you expand on that if that's what you want to do for the project. So for right now, when we create this actual grid, we'll set up as a default what the grid's going to be, like what its background color and cell will be. If you want that to be custom, then you'll probably have to add that in. Now, what we could also do is expose a cell. Okay, and you might have to pass in what row and column. So let's say if I have a grid, right, and I want to get access to, let's say, this cell, you would have to specify what row it is and then what column it is. Again, I'm not going to do that with you. I think maybe that's something that you can do yourself. You pass in the row and column, and then that'll give you access to the actual element that's at that particular location. Okay. Now, the way this kind of works is like this. So we're going to have a cell class, okay? And my grid is going to have to be an array of cell. Okay? Has to be. Okay, so when I create this grid in this grid class, this is what stores the whole. Once I pass in the constructor how many rows and how many columns I want, right? Then I'll be able to construct the size of this grid. Make sense? You have to when I do the constructor, I have to pass in the rows and the columns. Right? Make sense? Yes. So if I pass in the rows and the column, okay? So by using these, I get passed in by its constructor, and we're going to do this together. Don't worry. Okay. Then I'll create cell. It's going to be 2-dimension, and we're going to call it maybe mgrid equals new cell, and we'll pass in how many rows and how many columns we want this to be. Right? Pretty straightforward. It's just a 2-dimensional array. But my array is not of an integer type, not of a primitive data type. My array now is going to be an array of what we call objects. And this object is a cell. Once I do this, right here, okay? Now, if I just don't even put this part in here, this is pointing to null. When I do this, this thing here is going to point to memory. Okay, it's going to create some structure in here that has the number of rows and columns. Okay, but each one of these cells inside here in memory is actually going to just be a number or be a pointer to a location in memory to every one of these where these cells are, because those are objects themselves. Now, if this was an array of integers, this could get created in memory like this, and I would have all my integer values in there. Maybe it defaults to 0, right? So they'd all be zeros or negative ones or whatever after I looped and I assigned all the values. And they would actually have numbers in there. And then if I want to say I want to go to this this value at this row, this column, or this ij value, right? Row column value, I'd go there and it would give me the value straight up. It's stored right in there. The only problem is that this is not a primitive data type. I can't store a cell inside here because who knows how big they're going to be, right? Like it can't really tell. So what it does is it actually leaves some space in there to store a number in there, and that number is an address to where you can find the actual cell that's in there. So every one of these is going to point to another location, and this is the cell class. This one points to a cell class. Oh, somewhere in memory here, this will be a cell. This one over here is the cell, and that'll have its location in memory. So the number that gets stored here. So every one of these locations is not the value of the cell. It's just a number or a pointer to another location in memory, which actually then stores everything about that particular cell only. Because each one of these cells are independent of the other one, correct? This cell over here is different than that cell, is it not? Right? I could set the color for this one to be whatever, but the next one I can have a different background color. Right? So it has to go to its location in memory and set all those internal variables, its back color, its size, its whatever, in that location in memory about that cell. Okay? So once I do this, all I'm doing is creating kind of a location in memory, but each value inside there really is a null. So to start off, all these things, all these values in here are going to be nulls. Null, null, null everywhere. Until I go in and initialize every single cell. And this is how I got to do it. I'm going to see if I can do it here. So I would have to loop through. I'd have to create a loop through every single row, every column. So I'd loop rows. We're going to do it, don't worry. And then I'm going to do loop rows, and then I'm going to do loop columns. Okay, I ain't going to have room here to do it, right? To show it all. And then I would say something like mgrid ij equals, well, I have to use a new keyword. This is pointing to this location over here. It's null. So I have to use a new keyword to actually create the cell. And I would have to put in new cell like that. And I got to loop through every single one of them to create the new cell. Now that new cell, that's one of the constructors that we did, and that'll create a, we said 20 and with black and white, right? Now, all that, and then every single one of these will get assigned a location in memory, and then it'll assign it to black and white and size of 20. Black and white, size of 20. Every single one of these. And they'll all have their own little independent, I'm not looking like a fish, but its own little independent location in memory. So when you have an array of an object, every single element in there points to another location in memory that actually stores the value or values of that particular object that you're using. Or else, we wouldn't be able to contain anything in here. One could be bigger than the other, depending on what's assigned. Maybe I don't assign certain values in this cell, but I assign certain ones in here. So some of them might be null. Those would make them maybe different sizes. How can I fit that in that little space? And making sure that they always, it just doesn't work that way. Okay? This is huge. You guys can understand this, hopefully, after we do it and thinking about it a little bit, and you understand this, when you go on and you do other complicated things next year, when you learn about stacks and queues and all these other structures that they'll play on this concept. Just remember what I talked about here. Just remember what I talked about here, and remember everything's, when it comes to object, everything's a pointer to a memory location. If I want to switch this cell and put it here, put that one there, very easy. I just change the memory location of this one, tell it to go here, and copy that one over this one. It makes things way too easy. I don't have to copy the whole structure, so I don't do anything. I just copy this location, go here, that location, go there. Done. Right? I could reorganize these, order them, do whatever I want. Right? So this is fundamental to all these advanced data structures that you're going to do. You understand this, I think you're good to, and then you're off on your own after that. You guys can come back and tell me all the new structures and things that they learned today, because I don't know them. You want to learn a hash table, you're going to have to do this kind of stuff that's in there. You want to learn stacks and queues, you're going to have to do something about a circular list, whatever they are. You got all these weird things. But it's all based on these memory locations, and I tell you, when you understand it, if you can understand it here, you'll be able to take what we learn, extrapolate it to what they're going to teach you, and I'm not saying it's going to be always easy, but I'm just saying you'll know what they're talking about from day one. And then that'll help you to understand things much easier, hopefully. Okay? So really take the time to understand this, especially if you're going to continue computer science, and it'll make your life easier, big time. You understand this? You're good till the end of the second year almost. I don't know, you guys, your brother's there. He's doing advanced and everything's good still?
Yeah, he said the first year was easy. It was everything that he learned, and then I think the second semester, because he had each stream, he said it was a bit easy. It was kind of similar, but he did pointers and lists and stuff like that.
Yeah, which is more of this kind of stuff. Yeah. So because we don't do it every day, you're just getting a little case-like palette there, you know? Okay? But make sure, please, you understand this. Because this will go a long way for you. Okay? And that gets you through like first year, and you're breathing fine, right? So let's take a look how we're going to implement it. And I will, again, you know me, I repeat myself over and over again. Okay? So I'll repeat all the concepts that we're talking about over here as we do it. Okay? So we'll go slow. Please, if you get lost, if you're getting lost on something, chances are someone else is getting stuck. So don't feel that, oh, everyone's so smart and I don't understand this. I'm not going to ask because I don't. Please, just ask. Okay? I don't want to move on. I want to only move on if every single one of you understands it. If not, I'll say it in a different way. Okay? So what we're going to do is we'll close all this stuff down. And then we'll just create our grid class. Okay, so we're going to go back to our Ambro grid. and we're just going to add a new class. And this class that we're going to add, we'll just call it grid with a capital G, grid.cs. We're good. Add, and we're good. Let's just this time, let's just make sure we make it public, because then we won't access it. Let me grab my sheet here, because I got all my code in here and I don't want to forget anything. Okay, make sure your class, your grid class is, now let's go up to where the using are. We don't, I mean, we could delete those, and we're just going to add in the using system.drawing again. Okay, we got to add that in there, because we're gonna have to pass in the actual graphics object in here. Because technically, if you really think about it, I don't think we're gonna have to really even, we're not even really gonna need the cell class to access. Okay, we probably like directly. Well, you'll access the grid, and everything comes through the grid. Okay, so let's take a look at what fields we're gonna do. Okay, so let's put our little section in for fields, and we said that, well, the big thing that we need, if we go back over here, is this grid, right? We need the grid, and then we're going to need a grid that's stored internally. That's a two-dimensional array. Okay, so what we're going to do here is we're going to create a cell with two-dimensional array. Okay, boy. This, I'm going to call it mgrid, just like that. I'm not going to initialize it here. I'm just making it global, and we should probably put private in front. If we don't put private, it automatically is anyways, but I like to be explicit when I code. This way when you look at it, you know it's private. One language, if you don't put the access modifier in front, like public, private, whatever, static, some do it as public. This one does it as private. I think VB used to do them as public. So you go from one language to the next, and if you out of habit, you don't be explicit, it might actually give you a different access modifier. So it's always good. What's the big deal? You type in one extra keyword, right? We also said that we need to store the columns and the rows, right? So why don't we create fields for that? Because we're going to need those. So we'll create private, and then we'll do m rows. Oh no, those are going to be integer, m rows, and we'll do private. Actually, you could do it all in one line, right? We could do comma, m columns, like that. Only if it's the same data type. You could put as many with the same data type in one row. When I declare like this. So in the constructor, person's gonna say how big they want this grid to be. 20 by 20, 13 by 15, whatever it might be. 10 columns by 20 rows. So then we got to store that so that when we draw it, we have the rows and the columns defined so that we can loop through and draw each cell. If not, we wouldn't be able to get access to it. Well, yeah. It's good to keep it. Okay. I don't... Yes. Yeah, these rows and columns are going to be used when we actually initialize the array. Okay. So I don't think we're going to have any properties, but we'll do the constructor. We'll do one constructor. When you guys get the assignment, if you want to change this around, maybe you need two. I don't know. It depends on the assignment and how you want to implement it. So this should give you a really good idea how this works. So we'll say public. We're going to call it grid because that's the name of our class, right? We're going to pass in how many rows, int rows, and then int columns. Okay? And then this will be used to initialize our grid. Okay? we're going to use the new keyword to create the grid, and we're going to run the loop I and j, right, for all the rows and columns to actually initialize or create every single cell in each one of those grid elements, right? So the first thing we need to do is read in the rows and columns. So we'll say this dot m rows equals rows, and then this dot m columns equals columns. There we go. Okay, then we're going to create the array, and we'll say m grid equals new cell, and it'll be row m rows and m columns. Again, maybe in the end I don't really need to even store m rows and m columns, but it might make our code a little bit easier later on, so I don't have to use the get length. So this is fine like this. Makes it easier to read that way. So let's say I pass in 10 rows and 20 columns. So right now I have in memory on my heap, because it's an array anyway, so this goes to the heap. So in memory I have 10 rows, 20 columns, right? Each one of the cells has a value and it's null, because I didn't create the cell for each one of these cells, right? So 10. So there's how many of them? 200. 10 times 20, right? So there's 200 cells that are going to be displayed on the screen, right? And each one of those has to be initialized, because each one of those cells are non-existent until you actually create it by using the new keyword. So right now, right here, I have a cell that's 10 by 20, 200 cells, but they're all null. They don't point to anything. Okay, so the next thing I want to do is I want to initialize each cell in the grid. So I'm going to use two for loops, a loop within a loop, loop through all the rows and a loop through every column. And that'll give me access to every cell. Okay, so we'll do our two loops for int I equals 0, I less than m rows, I plus plus, j equals 0, j less than columns, m columns, sorry. Well, I could do this dot m columns, that makes it easier. And then j plus plus. Oh man, what did I do there? So I'm looping through every row, every column. This gives me access to each cell, which I can get by this dot mgrid ij. It's going to equal, and then all I have to do is use the new keyword. So I'm going to say new cell, and if we use the default, it was 20 white and black border, right? So I mean, I could be explicit. I could put in 20. I mean, we could just type it in just so we know. So I could do 20 color, background color will be white, and then color dot border black. It's exactly what my default is, but I typed it in like that just so way I could see it, right? And when I look at my code, I'm like, oh yeah, it's gonna come out like that. So now whenever I call this new cell, it's gonna go out. It's gonna put a number inside there, an address number. The cell gets created somewhere in memory, right? Every time it loops, each cell gets created in memory. That number gets registered inside the actual grid array. So the grid array doesn't even contain the cell. It just creates where to go find it. right? Just like the variable mgrid. It doesn't actually contain the grid. It just contains a number or an address location to go find the beginning of it. And then it knows based on what row and column you want to go to, or what index values, I and j, it'll go and find it. It skips over so many memory locations and boom, there it is. Okay? It probably just creates like an integer array or something like that, or a long. I can't remember. We'd have to look that up. I mean, you can look that. I'm not going to get that technical. But the thing I want to make sure is, does everyone understand why we have to use the new keyword for the cell? I will test you on it. Okay? I want you to know this. Okay? I put it on the exam, and I test for sure. I think I have it on the exam too. I'll test you on. So I'll just tell you to create. I'll just create a class. Tell you to create the class, write the code, whatever, and then you're going to create an object. Okay? Of it. Okay? If you forget to put this new cell in there, you're going to be. It's not going to work.
So can you explain why we use some
If I want to create, if I just have a cell object, right? So, like in our form, right? Whoops. So we go to our form, right? I wanted to create a cell, so I create a cell, and in order to create it, I have to call new cell, don't I? Then I can use it, right? So inside my grid, when I create my array of cells, okay, each individual cell is not created yet, because all it's doing is it's creating the array. It's creating an array, but in each location or each index of that array has to be a cell. But I also have to, because cell is an object and not just a primitive data type. If it were a primitive data type, it'll put its default in for it. So if this mgrid was a two-dimensional array of int, it will default and put zeros in for each value or index. But here, each index is a cell. Is a cell a primitive data type? No. It's an actual object. In order to create one, you have to, like you did here, use the new keyword. That is the only way you'll create one. A cell isn't created just by calling it a cell. If I just do this cell and put semicolon after here like this, it points to nothing in memory, right? That's basically what we did over here. When I do this, it creates the grid, but in each of the index values of the array, it's pointing to nothing or null, because I didn't use a new keyword. So it knows that a cell has to go in there, and I can't put anything else in there other than a cell, or a cell class, a cell object. But they're not created yet, so they're still null. So I have to loop through every single one and assign an actual specific cell to it, or it'll just be null. Just like if I went here and just did this. If I just did this, I create a location in memory that's a cell, but it's not even really created yet. It's pointing to nothing, because until I say new, then it knows how big to create it and what to create. So the same thing works with the grid, except the grid and the cell are both objects, so this new keyword gets used twice. Once to create the grid, the other one to create the cell in each one. That's a great place to stop, maybe. We'll review it again. I think that's good for you guys to try and digest this over the weekend. Okay? And what we're going to do is we basically created our grid right now, okay, with all the defaults. So then the next thing that we have to do, just before you go, is we're going to have to create the draw method to draw each one. A little bit, you got to think about how you're going to do that, because the cells move over to the right and then the rows go down. We're going to set its location where it starts. You guys are going to have to figure out the calculation for it. It's not that hard, but You gotta think a little bit. It's a pattern. We'll see who gets it first. Okay, so what we did the other day was we created our grid in our as a field, and when we created our constructor, we passed in how many rows and how many columns are part of this grid, right? And so we sized them. We sized the grid, okay? And then we did the looping through to initialize every single cell inside the grid to its default white color and then black border and a size of 20. Okay? So the next thing we want to do is draw it. So all we're really going to have in this particular class to basically get it going is the constructor and a draw method. Now I'm going to maybe do a little bit with you on the draw method just to see if you can, I want to see if you can figure it out, because you got to come up with the algorithm. So there's not a lot of lines, but it could be a little tricky. But let's just set it up first. Okay, so let me see where I am here. This is where my constructor is, so we'll go to the end of that. I think this is the last bracket. Let me double check. Yep. Okay. So what I'm going to do here is I'm going to do methods. Okay. And in this particular method, we'll make it public so we can access it. Void, and we're going to call it draw. And from what we were talking about the other day, we said, well, we're going to have to pass in the graphics object, right? And this will get forward, and this will get passed on to the cell, because the cell needs it. Because the cell is what really gets drawn. Grid, we need to pass it into the grid, because through the grid is where we draw all the cells. So I need that graphics object. So we'll put that in here again, graphics G. And we're going to pass in two other input parameters, and those will be the X and Y position, or the top and the left position. Remember we talked about that? The top left corner of where the grid would start on your screen. So you could position it right at 0, 0, or you could, maybe you got buttons or a menu there, so you move it down a little bit. So we need a position of where the grid starts. It's drawing, and then it'll go ahead and, depending on how many rows and columns it has and the size of the cell, that'll dictate how big it's going to be. And where, right? Oh yeah, turn off the light. Yeah. So we'll just create an int X for that, and an int Y for that particular functionality. Our opening and closing brackets. Let's just do a little line here. So draw the grid starting from X, I'll do X, Y, top left corner. All right. Basically, all we really have to do, in its most simplistic form, is to loop through every single cell and to call the cell's draw method, right? And the cell's draw method had the same parameters, graphic X, and the X and Y position of the top left-hand corner of that cell, not the grid. So we know based on what X and Y is from this grid, that'll be the position of the very, very first cell, 0, 0, right? But the next cell, depending on the size of the cell, is going to go over, well, in this case we said 20, right? It's going to go over 20 units, correct? Did we, why don't we include a private field for the cell size? How's that? And pass it into the constructor so we know what the cell size is. Because from the grid, because then we can use that in our calculation to determine where the next cell is going to be, the location. So let's do that. So let's go back over here, private int, and we'll do cell size, like that. And we'll pass that in to our constructor before the rows and columns, let's say. So we'll do int, oh, let's put an M cell size, sorry. So we'll do int cell size, this, and then we'll add it in here. This dot cell size, nope, yeah. What am I doing here? Equals cell size. So we'll pass it into our constructor so we know how big each cell is. Now, if you want to customize each cell to be different size and all that kind of stuff, you might. There's no way of doing that when you initialize it, because would you initialize? How would you make different ones for every single cell? So you'd have to come up with a more clever way of doing that. But we'll just assume that every time you make a grid, each cell is going to have the same size. Okay. So over here, where we inside our code as it's looping, you know how we passed in the 20? Why don't we just put this dot m cell size in there too? Okay. So we could. So when we create our grid, we'll say how big each cell is, and we'll say how many rows and columns there are. That's all. That makes it a little bit better. And we could use that cell size in our calculation down below, because we'll have to know the position of every single cell. Does everyone have that one in? I don't want to go. We got it in? Let's just do a quick run, make sure it works. Okay. Just to compile, make sure you don't have any errors. So now, my first, when I draw this, my first cell is going to be at 0, 0. Let's say I pass in, let's say whatever this x and y is. Let's say it's 0, 0. So it'll get drawn at 0, 0. It'll draw a cell out that's, let's say it's 20 for our cell size. It'll go out. Now it's going to loop and it's going to go to the next cell. So we'll probably loop by row and then by column. So it'll move over to the right. So the next position of it is going to have to be, while the y position isn't going to change, but the x position will go over the number of pixels depending on the width of the cell, which will be 20. Right? But we can use that variable m cell size to do it. Right? So every time we're looping within the second loop, which dictates we're reading the column next to it, so the x value is going to go up by whatever the cell size is. And then when we go down to the next row, we have to change the cell size back to what it started off with for the x value. We have to change the x value back to where it originally started. We've got to go back there, and then we have to go down, because it's going to display the cell on the next row below. It's better if I show it. I don't know why I'm verbally saying it. So let me show it. So when I draw my first cell, so we have x and y coming in, right? So the very first cell is going to be right over here. Okay. This top left-hand corner is going to be x and y. This x and y, right? Then I can draw, it's going to go over 20 in this one here, right? The cell that's going to get drawn next to it, we just have to tell its left corner. And this left corner is going to be x plus the cell, I'll just use the cell width, right? Plus y, and then the value of y. Y doesn't change, right? And then the next one over here, it's going to be, well, you can, if you're storing this value, it'll be another, whatever the cell width is here, right? So as we move over to draw the next position, it's always going over another cell size, which is in our case 20, let's say. So if our cell width is going to be 20, so this will be at 0, 0, let's say. This will be at 20, 0. This will be at 40, 0, 50, 60, 0, so on all the way to the end, right? Once I get, and that'll be the inner loop. Once I've done the inner loop and draw all the cells across here, I have to tell my variables that are keeping track, I got to go down now the height value. Well, the cells are 20 by 20, so it's going to go down 20. And then it's going to start over here. And then this coordinate here is going to be what the original x was plus y plus the 20, or the whatever the cell size is, right? And then this one here, it's going to go x plus 20, right? And then the y plus 20 stays the same, and for that whole thing. And then when we move on to the next row, it goes down another 20 in the y value, right? Or you add another 20 to it. Go back to the original spot where you started on the x value, and then you start going over. Okay? So you have to incorporate that in your looping structure. So in order to keep track of the variable of your positioning, I think what you need to do is to create a or not create or what did I write on here? We'll call it coordinate values, I guess. Coordinate values for looping. So those will be integers. Now you can use a little x. I just did a little px for position x. And then initially I'm going to set it to the big X. And then int py, I'm going to set it to big Y. Okay? So x, and I'm never going to change the value of the capital X and capital Y. I'll never change those values. So I always know what the original was. P and X will change. Okay? So the next thing you're going to do is you're going to loop, whoops, I'm not going to do it, you're going to try to figure it out. Loop through each row and column and draw the cell. Now when you draw the cell, you're going to do something like grid, mgrid. I don't know. As you're looping through, you'll have variables ij or rc, whatever you want to do it. So I'll just hard code it so it'll work. Let's say 0, 0, that's a cell. Remember we drew on the board? This is an actual cell, so if I put a period in there, I get all the values for a cell, and I will call draw, and then you pass in G, and you pass in PX and PY, because those are what keeping track. So you would do this call inside the two loops, but you got to change the X and the Y as you're moving along, and you got to figure out where those go. So I won't do any of that. I want to see if you can come up with that little algorithm. So as you're looping, it'll always draw it on the proper spot. And then what you'll do is you go back to your form over here, and instead of calling cell to draw, we'll take that out, and you could create the grid object. Grid equals new grid. Okay, we'll say it's a size of 40. And then, I don't know, we'll do 5 by 5. Okay, and then we'll do grid.draw. We'll pass in the graphics object, and we'll say it starts at, I don't know, 20 pixels over and maybe 50 down. This way it doesn't interfere. So that, why is this not working? It's probably not working yet. I haven't completed the. This has got an error in it, right? I think if I run it now, it would work, but it's not. No. Let me see what's going on here. Okay, let me figure this out and see what's going on. Oh, I'm using the wrong variable. There you go, lowercase g. There we go. I don't know why I did that. Okay, I used capital G, which represents the class, not the variable that I created. So that's why. Okay, so what you're going to do is you're going to create the two loops and code that sets the values for px and py, and then run it. Click on the form and see if it draws it. I'll get my code running in a minute, and then I'll show you what it looks like. But I'll have mine done before you, because I got my answer here when I did it last time. So I can do it fast. But I'm going to let you figure it out. Okay, so you try that while I hide the screen here. Okay, so this is what I used in the draw. There's other techniques of doing it. I did it this way. Probably you guys didn't probably do it this way, but what I did is every time I'm looping, so I came up with a little formula that specified what the position of y is based on what row I'm on. So when the row is 0, this goes to 0, this part of the equation. So it's just what the original y is, right? So, and then that sets that up. And then every time I go in the inner loop, that's basically to draw each cell as it moves to the right. I have a little formula here that also does that. So I did it that particular way. What you may have done it after the fact. Start off with x and y, whatever the original position is, and then you probably didn't put code here. You probably had it after, right?
Yeah, I did at 20 at the end of.
Yeah, you could. You should do. Should use an internal variable, a cell size, instead of hard coding in it, because if the person puts in a different cell size, then it won't work. So you got to use the cell size. So most of you probably did something like you probably did. So you probably did px equals x plus m cell size, right? You probably did it after you drew it. So then the next time it loops, it moves over for the next time and then draws it. Okay. And you probably did py equals y plus m cell size. Just that when you come, py would go over here. The only thing is that when you reach the end of the column, you have to reset px, so you have to put something in there for that. In order for me to avoid that, I just use that formula there, and it works. And it puts everything in alignment. So if yours works, great, but change any hard coding for any cell size values to m size, cell size. That's all. Yesterday we just did drawing of the grid. Draw. The video is there, so then I gotta just run it. So by that second half of the class should be done for you, and then you can add that in. Okay. Now, so if you got it working your way, that's okay, as long as it works. If you want to use my code, then you could go ahead and change it to this. Either or, it's fine. There's a couple different ways. Anybody do it this way? No? I don't know. It's the way my brain thought at the time when I did it. So again, there's some different ways. So my way is no more correct than yours, as long as it works, right? Okay. Now, one other little thing I want to do, because it's going to help you with the assignment that I'm going to give you, the little game you're going to make. It's not a really cool game or anything, but just to practice using classes and stuff. So what I want to do is, what if you want to get access to an actual cell? Okay. So we want to write a little bit of code to do that, because really, I'm just going to be accessing the grid, really, right? So through the grid, I want to be able to access an actual cell and then return the cell back so I have access to it in my calling code. And I can do different things with it, like maybe change its color and then redraw, right? I can just like different things I can do. So let's just see if we can play around with that and see what happens. So I'm thinking we're going to add another method. So I'm going to put it after here. And what it's going to do is it's going to get us access to a cell. So I'm going to make it public. And its return value is a cell. So that's what you have to put there for the return for the actual method. So you would just type in cell, right? So I don't have to return just primitive data types or void. I can return an array. I can return an array of multi-dimensional array, like 2D array. I can return an object, whatever I want. Anything can be returned from a method. So I'm going to say get cell, and we're going to have to pass in what row and column of that cell it is. Right? So if it's the first row, first column, that's the first cell. Now, with somebody using it, if I say first row, first column, that's technically 0, 0. So internally, we have to subtract 1 from all of these. Okay? It's easier if we ask the person to enter what row, what column, than to tell us what index. We'll take care of the indexing. So they'll give us the element value, and then we just subtract 1 in our code to do it. So we'll write int row, int column, and that'll give us the cell. We do this. Okay, we'll write a thing. Get a cell from the grid. Now we can put code in here to make sure that it's within the bounds of the row and the column, but I'm not going to bother doing that. And even for the assignment, you don't have to. If we were writing a pro application, we could worry about all the little details like that, but that'll just take up too much time. So don't worry about that. But if you were writing a real app, you might have to do something with that. So somebody puts in an invalid row and column, you'll just give them a message back instead of, but we don't want to go that detailed. So all we're going to do here is we're going to write return, well, we could do it like that. Return mgrid, and it'll be row -1, column -1. Whoops. Okay, it's not really a calculation. I know I told you yesterday, don't put calculation. That's not really a calculation. I'm just saying the -1. I could create 2 variables before, but I'm not doing a mathematical calculation in my return. So this will return us, because if I put a 1 in there, it'll come back at 0, 0. So mgrid 0, 0, right? Mgrid 0, 0 is this one right here, and it's the actual cell. And that's the cell, right? And then in my code, in my calling application, so in my form, I can get access to that cell, and I can do whatever I want with it. Right? So let's try this. Does everyone have that in there? So let's see. If we run it, it should work. Okay, it's compiled. Now I'm going to go to my test app under draw cell. And what am I going to do here? I'm going to create my grid. I'm not going to draw it, but before I draw it, I'm going to get access to one of the cells, and then I'm going to change its background color. Look at Phil. Phil's got that face on. He just had your look was like, I'm ready to tackle it. Not in a bad way, Phil. I'm just saying. He had a determined look on his face. So once I create my grid, what I'm going to do is I'm going to create a cell. I don't know. We'll just call it this. Let's just say, I know it's not a great name. Equals grid.getCell. Let's say we'll do the very first row and column. Mine's 3 by 8. You can make yours. So this will be 0, 0. And then what I could do is cell dot background color equals color dot, I don't know, let's just say blue. Okay? So if I do that, okay? So if I do this, I create the cell, everything uses default color. All my cells are white with black border. But what I did is I accessed the cell at 0, 0. I went in here, and I went into this cell, and I just changed its background color from white to blue now. So all the other cells still say white. So when I draw it now after here, when I draw it over here, what's going to happen is it's going to show all of them white, but it should be blue, or whatever color you pick. I don't know, did you guys run it right? Does it work? Hope so. So now when I draw it, came up blue. I got it. No. Jake, it's just your problem. So I'll post mine. So your algorithm's not correct, so keep going down. You don't want to go down every time you lose.
No, the blues goes there with the color. But you need to change the color. Yeah. Over.
Because you're using the I, which is the row, so it kept on going down. J, up, drop I. Did you get it to work? Okay? So now I can go ahead and do whatever I want with any cell and change it. I'm going to show you one other little thing. Let me just think. Sorry, I haven't been feeling well. I've been like extremely dizzy for like 3 days. What's going on? So let me see if my brain's thinking right. I'll show you. I don't know if you'll need to do it next. I may have shown the second semester last year, but I want to show you one other feature of polymorphism, and we showed that already, where it has many names. Yes, one face, many names. Sorry, like I said, I'm feeling a little off here. So one face, many names. We could create 2 methods with the same name, as long as they have different input parameters and stuff. So that's a use of polymorphism. Okay, we overloaded methods. What we can actually do is we can actually take an existing method that already exists and modify it a little bit. We could do that, but I don't know. My brain's a little off today, so I don't know if I want to do that with you. I have to explain. You know what? Maybe I won't do it today. Sorry. You'll be fine with your assignment in this particular way. Nah, maybe you won't.
Like,
Okay, no, you know what? Sorry. Let's take a look up here. I'm just looking at my form1.cs. Don't worry about this word partial. It's kind of a Microsoft thing. I don't think it exists. So you have a public class form. Notice that there's a colon there. Sorry, colon there, and then it says form. What that colon does is the last object-oriented feature that we're going to talk about. It's called inheritance. So Microsoft actually has a class called form, and they've created it. And what we did, even though it was part of the template, what happened here is I created a new class called form1, and then I said inherit. That's what this does. Inherit an existing class that already exists, right? So a class that already exists, an existing class, and inherit from the one called form, and that's built into .NET. That's part of one of the libraries, and it's a class that Microsoft has. Okay. So what it does is it makes this class form1 become a form. So Microsoft has all these built-in methods and all these built-in properties, all these built-in events, right? Like if you do mouse over, click on the form, all those are events. So all those three things are inherited. They all become part of form1. So form1 now becomes a form. And I don't have to do anything because once I write that class called form, which I didn't in this case, I borrowed it from Microsoft, and I said inherit that class, my form1 has all the features built in automatically from that class that already existed.
Excuse me, Zach, just a reminder to pick up your report cards that go home period quarterly.
Okay? Now, I could create another class. You don't have to do this. But, so just watch me here. So I could go to my grid, and then I could do add. Don't do this. Just watch. And I'm just going to call it another cell, or I don't know, cell a cell. Okay. Let's just call that add. So I could do a cell, and then if I do colon after it, I could type in cell. So now this particular class called a cell inherits from cell that we already created, right? So if I type in this, it won't let me do that. So if I do this dot, notice that it has all the built-in features of the cell because it is one. That's what inherit means. You get everything from the class. So now I created another class that's based on this one that already exists. So this dot, notice I got M border colors there, properties, it's got size, it has everything. I can even get access to these internal private fields too, I believe. So when we do inheritance, which I'm not gonna give you a project to do that. That's something you can learn later on. You don't always need to do it, but let's say you wanted to create a game and you have different kinds of people in your game. So I'll go with the game of Call of Duty. So let's say I have soldiers, and sometimes you might have different kinds of soldiers, but you might have a soldier and you might have a person, just a regular person that's in this game. That's a bystander maybe that you're not supposed to shoot. So maybe I create a person class that has all the attributes of a person that a person would have, and all the properties, all the fields, all methods, right? Then I can inherit a soldier class. I can create a soldier class, and I'll inherit person from that. So I have all the code there for a person automatically built into it, and then I could just add my own extra methods that relate to a soldier. Maybe they have some extra special things, right? And then maybe I have a bystander class that inherits from person, and that's just a regular person that's just walking in the streets of these games, right? Now, one of the things That makes all sense, right? Okay, just one of the things you can do is, it's called overriding a method, which we're going to do it, but on the form. We don't need to do it with our cell class. But what an overriding a method does is, if I am inheriting from another class, so let's say I'm inheriting from cell over here, cell has a method called draw. Maybe to draw this A cell is just a little bit different. So what I can do is I can override the draw method that has come from cell. So cell had its own method. I can override that and then change it so that when the person calls draw from A cell, the code that will get run will be the new code that I wrote, not the original one that comes from cell. It's a little bit, I'll show you an example because we need to use it to override something on the form. Last year we did the, remember with the timer, and every time it timed, it called the paint event, and it refreshed, and we could do the refresh in there, right? I don't really like using that. There's a built-in method that does the painting. It's called onPaint, and that kind of gets triggered off before the paint event does, and it's actually more efficient to use that method through some of the researching that I did with .NET. It's actually more efficient and reduces flickering and all that kind of stuff, apparently. So what I like to do inside the actual form is to override the paint event. And when I do that, every time a refresh gets called on the screen, I put my code in there to draw whatever. So you could draw your grid on there, right? So it makes it kind of neat. But it's another form of polymorphism. So I'm taking the actual code that already existed to paint. I said, do your job, paint everything, but add this extra little bit, which is the stuff that I custom to paint on the form. So the form gets painted plus the stuff that I get, plus the stuff that I add, like the grid or whatever. It's a very powerful way of doing it. So this A cell, I'm just going to delete, but we're going to go to our form, and just bear with me for a second. I think all we have to do to get access to this onPaint is that if you just start to, just let me do it. If you just type in override, well, I don't want to do it there. Override, and then notice you have all these things that you can override, and I want to override onPaint, and then just tab to accept it, and then bang, it puts everything in there for you. It's so nice. So you don't even have to remember. That's why I always forget, because the tool does it. Okay, so I'll do it with you again. I'll close the lights. So go inside your form. Okay, I'll do it with you again. Just go into a proper space. Make sure you're not inside any existing method or anything, right? Let me just reduce that. Okay, so this is my cell. So over here, I'm just going to say override the onPaint method, and then I'm gonna write down override, and then you just say you put a space in there and type in onPaint, and then you can select it from the here, and when you tab to accept it, it puts it in for you. And it'll put a word protected in there. That means that if I create another class from this one and inherit this one, it doesn't take this into account with the protected. But don't worry about that. We're not going to go there. There's so many things you can do with all this stuff. I don't want to really get into it too much. But I just want to use this feature. This is actually polymorphism, so you might want to make a little note there. Another form of polymorphism. I think I spelt it correct. Okay? So before you go to lunch, I'll explain what happens. So this on paint is built into the class form, and form 1 is our form, right? And it inherits that. So when you press play, your form gets drawn, right? It has plus, the minus up in the, it puts the standard toolbar in, and has a border and all that kind of stuff. That's all built in to draw that properly. That's all built in to that form class that we inherited from. It's all there. That's part of the base. So when I put this in here, base dot on paint. Okay, what that code does is it draws the original. It takes whatever was the code that was in the original class, like in the original paint method that was that Microsoft did in their class, and it just uses that and it draws it. And then what we can so it's good to put this in here right away. Okay, and then what I do is what we'll do is we'll put our code over here to draw stuff. So every time a refresh gets sent to the screen, whether you minimize it or something goes over top, what will happen is this on paint gets triggered off like an event, and it'll draw the base, which means the form, how it's designed, based on all the properties you set for it, centered and all that stuff. It'll draw it, and then we put our code over here, and then it'll draw our code over top, like the grid, and that kind of stuff. Okay? So it makes it a very elegant way of reusing the code that's there, and it works better, I find, than using that refresh event or the paint event. Okay, because it actually calls this for, and it's a method, and it's an easier way of doing it. You don't have to tie into the events; it's automatically tied into that refresh. Okay, so when we get back after the lunch, what we'll do is we'll use on paint to draw. Right? We're going to separate our code. All drawing stuff goes on paint, and which will be just draw the grid, and all of our logic code will go on the button when we click it. Okay? So logic code goes in the button. We could change whatever we want, set up how the grid is, set the properties of the cells and all that kind of stuff, whatever you have to do. That all goes there, right? And then once all that code's done, we could call refresh, and then it'll cause on paint to run. It'll draw the form plus all our customized code to draw the grid. Okay, so that's what we'll do when we get back. Okay, so what I want to do here now is I want to just change a few things so that we can make this our drawing, our section in our code that does the drawing, right? That draws everything on the screen. Okay, and then I want this button over here to be the actual, let's say, the logic of the game. So when I click the button, it does something. Okay, so one of the things that we have here is we have this grid. The only thing is that it's only alive within this particular button here. So we should make it global so that I can access it whenever anywhere in any method, and all the values and everything can be accessed. So first thing I'm going to do is I'm going to take this right here, and I'll put grid back here, and I'm going to go up here, kind of like what we used to do with the arrays, right? So well, it's technically a field, so we'll say grid. I want to see if I can actually put the whole command in there. Let me see. I wonder if it'll allow me to do the whole thing. Yeah, we can make a field. We'll initialize it. So when this form starts up, it'll create a grid of 40, and mine, maybe I won't do 3 by 8. Let me do, I'll do 8 by 8 or something like that. So I have the grid. Now when I click the button, something's going to happen. Okay, when I click the button, it'll just change one of the cell colors. That's it. Okay. Now all this drawing stuff, we're gonna take that out. Control X. Okay, so when I hit the button, all it does is it gets one of the cells in the grid, right? Changes its color. Okay, when the form starts up, it creates the grid. I changed it to 8 by 8. Okay, it's similar to what you're going to do on an assignment, so that's why I picked. So it's going to 8 by 8, 64 cells. Okay, and then that'll be available to us. But then when I click on a button, I just change the color of one of them. Okay, and then it's going to go over here and it's going to draw. Now the only time it's going to draw. No, that's okay. We can make it draw because when the form starts up, it creates the actual grid. So we'll paste that code inside here. Now, just 1 second here. I think if I do e dot graphics, yeah, there it is. We don't need to do the graphics object. We can just do right, or we can do it like this. Graphics g is equal to this this argument here that gets passed in e. It has graphics built into it. So we could do that. Oh, wait. I think it's like this. So e.graphics. This one. So let me just see. It should, when it starts up, it should automatically show. Yeah, it does. What's that? Yeah, it's passed in as a parameter. You could do so this way. You don't have to call this graphics. This e is a paint event argument, and what it does, it has a graphics object built into it. So when the form says to paint, it gives us the access to the canvas to draw on. So we don't have to call create graphics, because I bet you that create graphics has a little bit more overhead than using this e graphics, because it's really it's just passing a pointer around, because when the form gets created, it automatically, so it's probably a lot faster. I know there's like, when you start getting into this object oriented things, there's so many different ways of doing things, and you don't need to get fussed over what it does. As you study more and you become more, you'll learn all these little things, right? It took me years and years of working in the field doing this and studying it to get it. So in your case, this on paint, when it gets triggered off, it gives us the graphics object because it's part of the form, so it has a pointer to the surface to draw on, so we can access it and still, instead of calling create graphics, and then probably has a little bit less overhead, and then we can draw the grid. Okay, and then we dispose it at the end. Now when I hit this button, I want to trigger off the paint. So we could call this dot refresh. I think there's another way of calling it too. If you do invalidate, this is another way of calling. This is another way. If you do this dot invalidate, it says your screen or your form is invalidated, and then it causes it to redraw. So you could call this dot invalidate. Is it a method? Yeah. Invalidates the whole surface. You could even say invalidate a particular region of your actual drawing, of your actual surface. So maybe only a part of it gets blocked or something, and you have to refresh just a part of it. So it's much more powerful, but we won't use that. I'm just showing it to you. So you could use that too if you just do or refresh works. So refresh will call the paint event to kick off, but it calls this on paint first. So now we have a separation. So this is our, this is our drawing method, and then I'm going to go up over here and then say this is my logic method. So this draw cell, that button. So now if I go here and I click this, it should just, did that come out right? Okay. So I have it on the screen. It shows the grid when it loads up. It's all there. But then when I interact with it, things you got to call the refresh. Okay. You'll see why I'm doing it this way for you, because it's going to help you with your assignment, and then now you can build a game behind all this. Okay. So you're going to have to. You can pretty much use all the code that we've done so far to do the game. You're just going to have to kind of enhance it a little bit. Chances are probably not, I don't think I'm going to come to school tomorrow. I'm not feeling well at all. Just since Sunday, I've been extremely busy. I don't know what's going on. So hopefully you have enough today to work on it for tomorrow. And hopefully I'm here Thursday. My son's sick too, so maybe we both pick something up. I got from him, he got from me. I don't know. Okay. Let me show you what the assignment is. I'll keep this record because there's a few people away right now. So what you're going to do is you're going to create okay, please, the logic, the way the game plays out, nobody's probably going to want to play a game like this, but it's just, I made it into a game. Okay, so don't criticize me, please. Maybe it'll be fun, I don't know, maybe not. Okay, it's just to get you thinking, okay? So we'll call it assignment 5. This game is going to be called Tile Picker. Not nose picker, tile picker. Alright. Cherry picker, here you go. Okay, so what you're going to do is you're going to create a game where a player clicks on a grid of tiles. So all the cells, squares, whatever you want to call. I call each cell a tile now. Okay? To reveal a color and a point value. Okay? I mean, we could extend this to play games like memory or whatever. You can have like different things, but you know how you have the cards all flipped over and you flip over cards, and then if they don't match, you put them back, and then you, oh yeah, I remember that card was over here somewhere else, and we could make a game like that out of this. Okay, but we're not going to go that complicated. Okay, every color has a different point value, and so it gets added to the person's score. Okay, so basically what you're going to do is you're going to have this grid, 8 by 8, and you're going to randomly generate colors of the color types I specify inside here, and you're going to randomly place them throughout this grid. So you use the random code, and you can figure out a system of how you're going to do that. Okay, so that'll be something you'll have to kind of figure out. So everything, maybe all the tiles will probably look white until you click on one. Then it's going to show its color. Kind of like how I clicked the button, and it showed the. But this time you'll have to, when you click on an actual part of your actual grid, you got to do a little simple calculation to determine what cell you're in, and then it's going to reveal, and then it's going to refresh, and then it's going to show that it's now visible, and then you'll see what the color is, and that color will have a point value with it. Kind of makes sense? So everything's kind of, it's like having cards all face down, and when you flip them over, you find out what the value is of the card, and that's how many points you get. Now, not all the colors, the different colors are going to have different point values, and some of them are negative. And the object of the game is it's just a random game, right? You just pick so many squares, and at the end, you just say what your score is. That's all there is to it. So, yes, the game is not really mentally challenging or anything, it's just clicking. But it allows you to really get the idea of building like a simple game by using arrays of objects and things like that. Okay? So this section right here of this game talks about, you got 8 grids. It tells you what colors to use, and it tells you how many squares. Okay? There are 5 different possible point values. Okay, red gives you 1 point, blue is 2, green is 3, maroon is 5. If you have aqua, it's 10 points. And then you have brown and black give you negative values, -1 and -3. And then I tell you you're going to put 20 red tiles, 20 blue tiles, 5 green, so far. You can read those. It tells you how many to do. Okay? The tiles must be placed randomly throughout the game grid. So you got to kind of come up with how you're going to do that. Remember, when it generates a number, that might be occupied already. You use the random generator to do that, right? So as you start to fill them in, you're gonna, right? You can't you can't place over one that's already there, right? So you might come up with a system, say, well, check to the one to the right of it, and then put it there, and then it's done, right? You however you want to do the logic, it's up to you. Or you might just say generate another random number until you get one that's not being used, that doesn't have a color assigned to it yet, right? Okay. When the game begins, the player is going to select 10 tiles. So you have to detect when you click on the screen which tile you're over. It's not really that hard to do. There's a mouse click event, and when you do the mouse click event, it actually gives you what the X and Y coordinates are. So you know what the X and Y coordinates. Then you just have to do simple mathematical calculation to determine what cell it's in. Okay. If the player achieves, the player gets a score of over 30 points, they win. Otherwise, they lose. So there is some winning thing to it, or whatever. To try to make it a little bit fun. So we'll put it on one of those. We'll sell it for $1. Okay? Maybe stupid people will buy it, and we'll become millionaires. A tile can only be selected once. So when the person clicks on a tile, if they go and they click that same tile again, their selection count shouldn't go down. You should be able to detect that. Okay? And then when the game is complete, so after they picked all 10, what you can do is, I wrote there, all the tiles must be displayed. So you can display the tiles, you could flip them all over, and then they can see what all the tiles are. Maybe we'll leave that out. We'll see how hard. Leave that last. Maybe we'll take that out. To distinguish, oh no, I think I put that in there so that I could see your code to see where everything is. So when I mark it, I know that you did it. Yeah, so keep that in there. Okay. So to distinguish between a selected tile and a non-selected tile, you may decide to place a border around a selected tile. Well, a selected tile is going to probably have a color other than white. Like if you leave all your tiles like a gray or white color, so then when I click one, it's going to show a different color because I don't think any of these are white. So you'll know which one's selected already. So you technically don't have to do that, but you can add a border size in there if you want, and you can make it a little extra thick. See how that comes out. The game will require 2 classes. You can pretty much copy and paste cell in there, but I said use tile and grid. Okay, and you're going to begin development of this game by design. I want you to go into Word and I want you to design it. I know you could do it in the class designer, but I want you to do it in Word and to get used to designing your class. I know you could go in there and do it in the class diagram, but I want you to do it separate from there. Then you could go in there and do it, but I want you to do it by hand too and think about it. Okay, I don't want you just going in there and coding. I want you to always try to think about this thing here, about designing. Now, when it comes to this kind of thing, there's a number of things that you're going to probably want to do. So I'm going to give you some hints, especially if I'm not here, if I'm not feeling well tomorrow. I think what you're going to need to do is create a number of enumerations. Remember we did those? Remember enums? You want to probably create a number of enums. Doesn't matter which class you put them in, just make it public, right? So you're going to need a number of enums. Does everyone remember those? We did those? Right. Okay, so you're probably going to need an enum for, let's say, this. I'm just thinking out loud, so you're going to have to fine tune this to make it work. But I'm thinking you're going to need an enum to determine the state. Something with the state, whether it's flipped or selected or non-selected, right? So if I have my grid, whatever, pretend that's 8 by 8. If I click on over here, it'll now identify that it's selected. And when it's selected, when I redraw the whole grid, what's it going to do? What do you think? If I select that grid, And when I redraw the grid and I selected it, what's it going to do? Based on kind of what I told you about how this game works. So when you click on something, what is it supposed to do? Show the color. So if the state of the cell is selected, what does that mean? What's that? Yeah, it means show its color, right? Right? So you might have it, you're going to need something that's going to identify the state of each cell. So this will be, let's say, for the cell. These ones are for the cell. Also, every cell is going to have a color, right? So it's going to be one of those, what did I call them in here? We'll just call it tile color or whatever. This is tile, not cell. But it's pretty much the same thing. So you're going to have a color, right? And then that'll be all the ones that you have over here. So you'll have blue, green, maroon, aqua, right? So it knows how to draw it. So you might have an enum that says which one it is, and then depending on which one, you have a bunch of if statements. You draw it. So if it's non-selected, you have your default color that it draws it with. If the tile color, what should we call it? Selected color? I don't know. What's a good name for that? Don't call it color. You have the background color. Well, maybe you can use it just to set the background color. So you use this enum to set. So if the state is selected, you won't even check what the background color, what the back color of the enum is, or what the tile color is. Okay. So if it's not selected, then it just shows the default of white, back color. If it becomes selected, then the tile is going to be one of these. It's going to be blue, green, maroon, aqua, or whatever, right? So you need probably in your tile, you'll need some sort of property that's going to indicate, what the state of it is, right? What the color of it is, what the tile color is, right? So some of these enums are going to probably apply to some property and correlate, right? So if the person's non-selected, its default color will be white or gray, whatever you decide to make your game, right? Like the back cover. Think of them as cards. It's the back cover color of the card. But what is it hidden as? Well, maybe its actual color is maroon, right? Because that's what the card is. So when it's selected, the maroon it'll draw the maroon as the back color, because that's what it's going to show on the screen, because now it's selected. So you got to keep track of the state, whether the person clicked on it or not, right? And in the tile color, that's what will be used to show, like the draw on the screen. So that tile color will probably tie in somehow with the background color. Somehow it'll be background color. So you probably have to figure out a way to do that. I'm just giving you some hints, right? Now maybe you might need an enum. No. Maybe even in your grid class, maybe you have a private variable that keeps track of selected values. So you know when you get 10. It's probably some sort of integer. That might work out. If not, you're going to have to go through all your tiles. Every time a person makes a selection, you're going to have to count up them all. You have to loop through the array. Why would you do that? Just have a counter in there. So whenever someone clicks on one, as long as it's a already non-selected value, then you know that goes up by 1, and then redraw it and show it and add the points. You're also going to have some sort of based on the color, it's going to have some sort of point value, right? So your tile has to have a property or an internal field with some sort of point value. So whenever you create the tile, you set its color to green, let's say green has a positive 3, you have to set its point value to 3, right? So the color gets set to green, and then the point value gets set to 3. There's a lot of little things. Now you start to, right? So as you start to look at these things, you see that there's a stupid little game like this, and I already gave you the hard part of the code, right? We already went through well, but still to implement it, we got to add in quite a few little things, okay? Just to make this thing work properly. So my suggestion to you right now is to, when you take a look at this tile, you got to look at these rules over here, right? Determine what properties you need to keep track of those things, right? And then you may need to create corresponding enums to do that. I would use an enum to do it, as opposed, you could create your own numbering system, like a 0 means this color, a 1 means that color. It's better if you use an enum, right? You can't assign it anything other than what the enum is, right? So we did that. So I think I think we did it in the employee class, is it in there with the gender or whatever, so go back and look at that. So you're gonna tie in a couple little things, okay, but the bulk of the code's already done, you just have to modify it. When you draw it on your screen, I mean, you could have it come up, if you put a menu in there, like I don't want you spending too much time on UI, I didn't have time to actually create one for you. But if you have file, maybe you just have start game and new game. Maybe you just do like a start and a new, okay, and then an exit, okay, and then you could have it come right at the edge. So you can make the grid come right over here. But if you have a menu system on there, you got to put it down. I think it's about 20 pixels.